Well, hello everyone. Welcome back to Adrian's Digital Basement 2. On today's video, I am going to try to address one of the last things that's wrong with the Amiga 3000 I've been working on, which is sitting right back there on the bench, and it is the floppy drive. Well, and besides the floppy drive not working, someone wrote dead on here, the flicker fixer isn't quite working properly on the Amiga, but right now I just want to kind of get that thing back together so it's complete. I'll work on the flicker fixer at some point in the future because I don't necessarily need the flicker fixer. I can use my Commodore 1084 on that computer perfectly, and everything else on there is working perfectly. So it's really this floppy drive. Now, I know if you've watched any of the videos where I've worked on this machine, you might be thinking, well, you were using the floppy drive, and that's true. I was using this drive here. It's a Teac 1.44 meg drive that I have altered to work on the Amiga. The problem is the Amiga 3000 has, well, if you just sort of see it back there, it has the front plastic bezel. And the floppy drive that comes with the machine, which is this one, is designed to fit through the opening on that machine. And this is a Chinon floppy drive, the FB-354. That's the model number, that is. And, well, you need one of these for that to work. And, well, you can just kind of look when you compare these two. The Teac drive is totally different shape. It's thinner. Nothing is going to line up. And obviously, the plastic on the front of the machine is fixed. That's not just a faceplate you can pop off. So I want to try to get this drive working. I don't know what's wrong with it exactly. It just says dead on here. And when I did try it briefly, it just seemed to do nothing. So I don't really have much hope in trying to revive this drive. My fear is that someone plugged the power connector in backwards because the power supply connectors on the Amiga 3000 aren't very good at being keyed. These are bird connectors normally on floppy drives like this, and it's not very easy to flip them around. You have to really force it on. Unfortunately, the ones that Commodore used were not the standard Bergs, which if we take a look at this adapter here, this is a standard bird connector. I think I have that terminology correct. So it's got a little line on the top there, and you can kind of see the shape of it. That means that when you plug this into the drive, if I get this lined up so it's focused, there we go, focused, then this goes on just like that really easily. And it's not easy or really even possible to get it on the wrong way just because of the keys and stuff that are on there. But like I was mentioning, the Commodore one, it doesn't have the same kind of key stuff going on like this does. And I wonder if someone just plugged it in the wrong way. When you do that, it sends 12 volts into all the 5 volts electronics. 12 volts is probably used on this for the motor and whatnot. I think on these newer drives, generally 5 volts is all that's used for the whole drive. I don't think it even uses the 12 volts at all, although I might be incorrect about that. I don't know, I never really looked into that. But with this drive, it probably uses the 12 volts. But if this was put in the wrong way, then, well, I just don't know. You have to imagine that everything is kind of blown up on the main board. But maybe there's a fuse. Maybe there's something else that's wrong with it. I don't know. Okay, so that's what I want to work on. I want to try to just diagnose this drive and try to figure out for sure if it's dead. And I've done a little bit of research, and I'll show you that in a second. And as far as I can tell, the only drives that will work on the Amiga 3000 are this exact drive. Well, I mean work as in be able to be mounted into there. FB-354 from Chinon. Same drive that's used in the Amiga 500 from my understanding. Different than the Amiga 2000 drives. And unfortunately, I don't have any spares of these. I've had a few Amigas over the years where this drive, the Chinon drive, has gone bad just due to corrosion and stuff like that. And I'm kind of short on these drives anyways. I have lots of PC-style floppy drives, but these, not so much. With an Amiga 3000, 2000 and 4000, the opening in the case is just designed for a normal faceplate. It's the same width as this drive. It doesn't have the kind of cutout that the 3000 has. So if you try to use a PC drive in those, it's not a big deal. You could just use little spacers just to get it mounted correctly. And you'll either have a little bit of a gap underneath, or you can just 3D print a little spacer that goes underneath the normal PC style bezel just to fill up that space. And the drive otherwise works, like this Teac drive here is working. Let me talk about how you can make these work in a second. But the Chinon drives, yep, they're just not common. I don't have any spares. So if this thing doesn't work, like if I can't figure it out in this video, what I'm going to have to either do is just use a GoTech, I guess, in there, or try to buy a working Chinon drive. And, you know, we all know that floppy drives are kind of an endangered species. I personally like having a real floppy drive inside my computers. I don't really like to put GoTechs in there. What I have, and I know I've shown it previously. It's up on the shelf there. It's a regular looking Amiga floppy drive, like a 1010 is the model number. It's from the original 1000, but I've replaced the faceplate with a 3D printed one and it has a Gotek in it. So I do have an external Gotek I can just plug into any Amiga, and I'd just like to try to figure out how to get this drive working. So very long-winded intro there, if you could call it that. First, let's take a look at this Teac real quick, because like I said, this is configured for Amiga drives, and let me just show you how, or Amiga use, let me just show you how that works exactly. So when you look at these Teac drives, these are pretty common, and the model number on this is the FD-235HF. Now the issue is that there are many, many subvariants of this particular model number, this FD-235HF. This means it's a 1.44 meg drive, and that doesn't really matter for the Amiga, just as long as you use double density disks, there is no issue whatsoever. What makes this drive possible to work without any kind of mods, I don't have any bodge wire soldered onto this at all, is that this particular Teac has all of these jumpers here. Now, one of the problems is there are many, many subvariants, as I just said, about with this floppy drive, and many don't have any jumpers, or maybe they have a single jumper just for the drive select, like 0 or 1, or maybe they have some of these. So when I researched, I went to my stash and I picked out this drive and I just wanted to research which drive was going to work. Well, what you have to do is you just have to start searching around the internet and looking for the exact number after the main model number. So this is a 3240-U5, and then that will lead you to information on how to set up the jumpers, maybe. Now, as far as I'm aware, there's no single guide as like, here's how you do it. This is what you do to make it work. That doesn't exist. But I was able to find some very sketchily scanned service documentation for this drive. So FD235HF-3XXX. That means that what I found is good for any of these models that have that. This is a 3240, but I suppose there are other versions, subvariants, and this layout of jumpers is appropriate for any of those. Now, what I've gone ahead and done on here is marked this for how I figured out, after just sort of experimentation with the jumpers on here, how to configure it for Amiga operation. So if you have one of these drives, the 3000 series, and those jumpers are configured in some specific way for use on a regular IBM PC, if you set the jumpers where these yellow marks are, this drive will just work perfectly on an Amiga. I assume it will work on all the Amigas too, but on the 3000, works perfectly. You can take the disk out, put the disk in, it detects that. The only weirdness is that the activity LED flickers as the drive is accessed. I mean, I don't mean quickly, but it's like it doesn't work like you would expect, where it sort of comes on and then turns off after a second when the drive stops accessing. I don't think there's any way to fix that. Maybe there's a bodge you could do on the bottom for that. But this is the jumper configuration for this drive. Now, I didn't really know where to post this, so I just put it on my Bluesky account. So if you ever wonder about this and you have one of these drives, then go to my Bluesky, and there's a photo of the jumper configuration that's on this drive right now. And then of course I have the little picture that I was just showing you. I did have a follow-up post showing how it looked when this drive was configured for use on a PC. So that would be drive select 1, because it's going to be using the twist for like an IBM PC cable, and all the other jumpers were in this configuration. That's how I found this drive when I went into my stash. So if anyone wants to grab these pictures and put this on a wiki somewhere, feel free, but it's there on my Bluesky, and well, from May 12th. And that's how this drive is currently configured. So what I want to do in this video for troubleshooting this drive is I don't want to use an Amiga to do it. I want to try to use a PC, but I don't really know what will happen if I take an Amiga floppy drive and hook it up to a PC. I find testing with a PC, like using IMD as a good diagnostic program for floppy drives, is just a lot easier than trying to do it with the Amiga. I'll get this hooked up to a PC, a regular IBM PC AT. We'll use it in 720 mode. I'll configure the BIOS for 720K disk mode, and I want to see how this works. Once this is up and running and we can kind of probe it, move the heads around, stuff like that, then I'll switch over to this Chinon drive, and I want to see if I can get some science of life out of this. I'll obviously have to take this thing apart so we can take a look at this main board, see if there's anything obviously wrong, see if the power's getting through. But like I said, it's always good to start with something that is known good, and I happen to have this drive, so let me grab the test bench and get set up. I'm sitting here getting the test bench set up, and I'm thinking to myself that something like the grease weasel could probably be really useful for doing diagnostics on disk drives. Obviously, it's designed for driving the disk drives, and it can, to some extent, do that. But maybe someone could make a front-end utility that could offer a good graphical representation of what the floppy drive is doing through Grease Weasel, or maybe some custom firmware for the Grease Weasel. So you could check to make sure that you're able to read all the sectors off of a track, like you just, put it in a known good disk and are able to move the head back and forth and off track, on track, that kind of thing. Check for the density, check all the signaling, something that would be easy to use with a just plug the drive in, plug it into a grease weasel, plug it into your modern computer, and then just have a front end to diagnose the disks. I know there are certain commands you can check the index pulses, like how fast the drive is running, but those are all just trigger one commands. I want something that can just turn on the motor, check the index pulses, report that back, start moving the head around, land on a track, continually read that track just over and over again. And if it's supposed to be 18 sectors per track, show 18, 18, 18, 18. Then if you start fiddling with the disk drive, say you're getting the alignment right or whatever, and then it's 17, 14, 12, 0, it's not reading the track. Or you're reading sectors, but it's reading them off the wrong track. IMD does all that stuff, which is why I like using it. If you are reading track 10, but the head is actually positioned on track 9, IMD will tell you that, hey, I'm reading good sectors, but they're coming from the wrong track. That kind of stuff is very, very helpful. So yeah, if someone out there is super smart with this stuff and could develop a super duper diagnostic utility for the grease weasel, I think that would be fantastic. Okay, so I have my 286 test bench out. I've shown this a million times on the channel. This is the one that had SIPs originally in it, and now it's running with SIMs because I swapped those out. And we have this thing running at, actually, it looks like this is running at 8 megahertz right now. It was overclocked, but I have declocked it. Let's just check real quick what this thing is running at. Maybe it doesn't really matter. We don't need it overclocked for this floppy drive testing, do we? But I have a little pile of crystal oscillators. Yeah, 8 megahertz is what it's currently at. I know I had something faster in here originally. Was it one of these 28 megahertz oscillators? Boy, that oscillator barely makes contact in there. Yeah, look at that. It's actually booting up. I think this thing can actually run with good stability at 14 megahertz, 14 point something, which is what it's going to be running at right now. Looks like I have a 20 megahertz Harris processor in here as well. Yeah, 14.213 megahertz. That was a little bit of a side quest. Sorry about that. Let's get back to the floppy drives now. So here's the Teac drive. It's plugged in. I'm using a standard PC floppy drive, but I do not have it connected after the twist. It is just connected on the straight through portion, which would normally hooked up to a normal PC. If the drive were configured normally, it would be the B drive, the second disk drive. Let's see if this is able to be read at all by the computer right now. Okay, I just have to spend a second to figure out why this computer wasn't posting. It was the oscillator that I put in, that one that was running at 14 megahertz, wasn't making good contact with the socket. That's a cheap socket that I have in there. I'm going to have to fix that. Now, while this boots, let me just sort of pontificate on floppy drives a little bit. When people are getting or resurrecting their old retro computers, floppy drives are kind of the bane of everyone's existence, because unless you have a bunch of drives around and you have known good drives, it's very difficult to troubleshoot these things. Oh, it actually seeked. Interesting that there was no drive even configured in the BIOS, and it did seek the disk drive. I didn't try to boot off of it though. Anyhow, as I was saying, you can have bad disks, you can have bad cables, you can have bad floppy drive controllers, you could have bad power supplies, you could have the bad drives themselves. There's so many things that can go wrong that can just make it really difficult to troubleshoot. And a lot of people sort of go to oh, maybe my drive's out of alignment. This is my personal opinion. I've worked on so many computers, and I really have never had to do drive alignment. On modern drives like this, especially where it uses pretty precise stepper motors, and even the 5¼ inch half-height drives, very similar, you don't generally need to align those things. So if you start fiddling with the alignment, you're pretty much going to guarantee that you're going to make the drive worse, most likely. Now, it's not to say that no drives ever needed alignment, and especially the older drives with the large, big stepper motor and stuff, maybe those, it's more common. But even Apple II drives, which headbang every single time you turn the computer on, that's what that noise is, that's the headbang. They generally are fine. Commodore's headbang a lot too, 1541s and so forth. Anyway, okay, let's go to IMD. I think it's actually in my path already. No, it's not. IMD stands for Image Disk. Dave Dunfield made this program back in 2005 through 2022. Highly recommend playing around with this if you're ever trying to just sort of get drives working. Obviously, this is not going to work with Macintosh drives, Apple II drives. It's generally for this SugarArt style interface that 8-inch, 5¼ inch, and 3½ inch drives we use, standard PC style ones. And the Amiga drives are close enough that they generally work. So you go to the settings and you can pick whether it's the A or B drive. I think this is going to be showing up as the B drive. It is an 80-track drive. It is double-sided, so we can set that. Double step needs to be off. That's where if you're reading a 40-track disc in an 80-track drive, you need to double step it. And the rest of the stuff I'm just going to leave alone. And now we're going to do alignment test. Okay, the drive is accessing, but does it read anything? It does not appear to be able to read anything. So that's my assumption. And the drive LED is not even on, actually. So this might be a bit of a problem with the way the jumpers configure this drive. Like I said, this drive 100% works. I'm going to grab a regular PC disk drive. We'll just test quickly with that. Okay, so we'll try this drive, this sort of Epson drive, just configured for standard PC operation. I just want to make sure that the disk I'm using is good, and that, you know, the cable and everything else here is working properly. So let's just get this plugged in, plug in the power. And yes, I am hot plugging this. Okay, I'll switch this disk over. Let's see. So it says insert formatted disk. It was not happy with that. So alignment. Okay, so the drive light is on. Oh, there it is. So this works. There's no speaker hooked up. If I had one, oh, I have one right here. Let me plug a speaker in. It has an auditory feedback mechanism, which is quite useful, to be honest. Let's get the speaker hooked up. So basically, if I change tracks, see, like it had 112 and then back to 18 and the frequency changes. We don't need to hear that. I'm going to unplug the speaker. The reason why that happened is because obviously when I switched tracks, the disc was in the middle of spinning. So it's only able to read a certain number of tracks from that particular track, or sectors, I mean, from that track. And that read 12. And then the next cycle, when the disc spun again, it read 18. This is working. If I take the disc out, you see it just sort of stops, put it back in. It does resume. You can recalibrate, which, you know, makes the heads go back and forth, like when you turn the PC on, stuff like that. Okay, anyways, we know the disk is good. We know this drive is good. We know the cable is good. But definitely we're having a bit of an issue where we are unable to use the Amiga floppy drive to actually read anything. Now, what I'm going to do, what am I going to do? I'm going to plug in the drive after the twist and just see if that somehow makes any kind of difference. This is the Amiga drive, that is. And I guess the problem with all of this is that IMD is not a good program for testing Amiga drives. I mean, I'm not half surprised, but that is just the truth of it. Okay, so it is back in. Let's see if I exit out of here. When I put the disk in, and I'm going to try to do alignment again. It's weird, like I hear the head seeking, but the drive's not even spinning and the light's not on. So obviously it's not going to work when it's like that. Now, in case you're wondering, by the way, I do have the cable on correctly. There's pin 1 on the drive, and that's the stripe, and you know, it's all hooked up correctly. That just means that without some kind of an adapter board, which would probably be possible to make, yeah, you just can't test these drives using IMD. So one more time, alignment test. So the drive is spinning now, but the light's not on. So I don't think the drive is being selected. There are 2 select signals that come from the controller to the disk drive. There's a motor on signal and a drive select signal. Obviously the drive is getting the motor on signal, but the drive select signal is not coming through. I have one other idea. What if I try to use the Amiga floppy cable? Because notice it has a little mini twist here, different than the PC twist. That's the twist on the PC drive. So what if we try to use this one? Let's use that. So while I was using this drive on the Amiga, by the way, I was always just using this exact cable, and I had the drive plugged in like this. Yeah, interesting, like without any twists. And I don't know on the Amiga, is drive DF0 this with the straight through, and is this drive 1? I don't know. Now it goes without saying I could just reconfigure this drive to work on the PC, but that's not the point. I want the Amiga drive, the other one that's not working, to work. Therefore, I just want to use this in the Amiga configuration to see if I can get it to work. That's why I'm not reconfiguring the jumpers right now, because this one doesn't have jumpers to reconfigure. It only has drive select jumpers. And it is currently set to drive select 0, DS0. I'm pretty sure that's how this one is set as well. Now maybe I'm going about this the wrong way. You could totally argue that. Maybe I should have just dug right into this Chinon drive and just tried to figure out what was wrong with it without doing all this stuff with the IMD and everything. But I want to be honest here, that I would like to know if I could use IMD for Amiga drive diagnostics, and I think the answer is going to be no. The drive did just seek, by the way, but it didn't turn on the light. So I think, again, that's our same exact problem, even with that twist in the cable. All right, so here we are in IMD. We'll just set this up real quick, and we'll go align. Okay, so the drive is not even spinning right now. That is what it's set to A. So we're going to go back to the setup, and we'll change it to B here, and now we'll do align. Now the drive is spinning, but the light is not on. Okay, so yeah, the drive's not being selected. That way, there's no way this is going to work. Now there is something I could try. I could just add a little tiny jumper wire between drive select. I'm just trying to think if this would work or not. So the motor on signal is obviously getting through, but drive select is not working. So I could add a jumper just on the bottom of the drive to hook those up together. I've at least answered the question that I wanted to answer, and that's you can't use IMD with a normal PC floppy drive controller to work on Amiga drives without modifying the drive and or creating some kind of an adapter board. And that's even if you use the stock Amiga cable. I'm thinking now, because I do have extra floppy drive controllers, that I might modify one of those so that the pinout or whatever's going on with the drive select and motor on signals would go to the correct pin. So I'll modify it on the controller side so that way it's designed to only work with Amigas, because occasionally I do need to do this troubleshooting on Amiga drives, and if I can make this work, then great. In fact, maybe I'll get to that in this video. Let's take a look at this Chinon drive first and just see if I can get any signs of life out of it. Because at least with IMD, I can make this like spin and seek. So that's a good first test, just to try to get this thing to have some sign of life. Yeah, so here's the Chinon drive. Visually, I don't see any issues, but we can barely see anything looking at the bottom here. So let's take this board off here and just take a look underneath. I recall when I tested this on the 3000 while that Teac drive was working, this one didn't do anything at all. Just totally dead. And that, again, leads me to believe that there's something just blown up on here or something like that. I don't know how this all comes apart. I assume I really need to take this outer shell off. There's a bit of corrosion on this as well. Now, James, who gave me the Amiga 3000, mentioned that this drive, I think, never worked properly, even since James had the machine. And I think a GoTech was in use with the 3000 when James was using it. And this was, I think, marked by someone before him or him. I can't remember exactly what he said in the emails. All right, so with the screws on, this comes out. With the screws out, that is, the top comes off. There's our drive. I mean, it's dirty a little bit, but it's not terrible. Now, I don't love the design of these drives, by the way, because of this plastic scaffolding. I've had drives where these little posts break off and this whole thing just becomes loose, and then that makes the drive just kind of useless, unfortunately. Now, of course, we do have electrolytic caps. You see 3 of them right there. This could easily, or they could easily be leaky. But I don't think that's necessarily the case, that if we have some of these that aren't working so great, that the drive would act totally dead. All right, one good thing I can see here with the cover off is that this drive is connected, or this board is connected to this other board, the speed control board, motor control board, through a connector there. And that's just a little holder from what I can tell. So I think I could just pull this forward, and then I'm gonna have to disconnect the heads. And this wire, which is probably track 0 sensors, and this, which is gonna be the stepper motor. But let's first see if this comes off of here. So let's see. Yep. Okay. There we go. Actually, you know what? Shouldn't I test this before I even take this apart any further? Yes, I should. Everyone's probably screaming at the screen. What are you doing? Okay. It's back together. Let's plug this all into this power supply and just make sure that we got voltage coming through. You know, that it has the potential to actually work. And I'm going to plug in the PC cable. Now I just looked at pin 1 is on this side, pin 1 and 2. So there's the stripe. It's usually towards the power connector, but not in this case. Okay, so make sure this is all, yep, we're looking good. All right, let's power this up. Might as well put a disc in. Where's my disc? It's in this other drive. It's in the other drive. Let's get this into here. Yeah, there's like no signs of life. Like normally when you put a disc in the drive, it should like spin up for a split second just to kind of get the disc latched in there. It's not doing that. Yeah, I really think this drive is just totally dead. Gonna grab the multimeter here so we can probe around a little bit. Whoa, wait a second. It's not dead. The head's moved. You gotta be kidding me. Wow, okay, so this is very interesting. We have signs of life. I was wrong. All right, well, let me try aligning this and see if the disk spins. No. Insert formatted disk. Said that immediately? Oh yeah, right. This is just like before. Oh, the light, the LED, the activity light's on, but it's not spinning. Okay, so this is a different problem. I just thought this drive was like stone dead, but the activity light's on. We saw the heads move, but it's not spinning. And I'm positive that this should be spinning right now, but maybe not. Let's check this, or change it to drive select B, and let's do this again. Same thing. Light's not on now. Heads are not spinning. Okay. Well, that's a different problem. This could easily be caps. Wait, did it just literally spin a second? I was looking away. Let's change this back to A. No, I don't know what that was. Just poking around. Yeah, it's funny that the LED was on there. So that didn't happen on the Teac drive. Let me try to show you. I carefully lift this up. Okay, so there's the LED right there. If we exit out of here and hit align, see? The LED is on right now. So I guess the real Amiga drives work slightly different than the Teac drive when it comes to the way the drive LED works. It does turn on the Amiga, or the Teac when it's plugged in the Amiga, but it doesn't stay lit. I wonder if the LED on this drive is tied directly to the motor on signal, which I think is different than the Teac drive, which I think the LED is tied to drive select, which is why it kind of pulses, because it only turns on while the Amiga is currently talking to the drive. As soon as the Amiga stops talking to it, even if the motor is spinning, the drive doesn't actually do anything. Okay, well, I'm happy about this. I mean, I wish we could get better test results out of IMD, but the fact is this thing is showing some signs of life, which is excellent. That means that there's a possibility here. Maybe the problem exists entirely on the speed controller board. I wonder if I should just like double check all these connections. Let's do that. I'm just going to plug this back in real quick. Like that. I'm going to use the multimeter and just tone out these connections right here. I mean, that's just sort of a basic trial and error 101, right? I don't see any electrolytics on this speed controller motor control board, but that doesn't really mean anything. I was going to say they could be underneath, but I don't think so. That PCB is right up against this metal structure. Almost certainly on the other side of this, there's actually the main controller IC. I know we don't really see anything right there, but it's probably under there. And the outputs of that speed control IC probably make their way directly to the windings of this motor. So under here will be coils and some Hall effect sensors, and that all comes back over these connectors back to whatever chip is handling the speed control. Now that chip just could be bad, and in that case, you know, we're kind of out of luck. But this stuff is labeled here: ground, VCC, write protect. There's LED, D1, ID, HS, HD, and MON. Don't know what those mean, except, you know, for the ones that are obvious, like VCC, write protect, LED, but the rest of that stuff. Now, one thing that this drive will have here, there are two micro switches, one there and one next to it. One is going to be used, sorry, it's out of focus. One's write protect, and the other one is going to be used for drive select, or sorry, disk inserted, so that the computer knows that there's a disk in the drive. And those come back through these contacts here. In fact, looks like DIS is actually what's labeled there. So my assumption is what says DI right here. This may be disk inserted. Disk inserted sensor, disk inserted. Well, let's use this to just sort of tone out some of this stuff. We know that the LED is working, so that doesn't really matter. Let's check the little sensor here. So DI, yep, there it is. And it says DIS right here. Okay, so there are two connections there that look good. Obviously, write protect, I mean, I don't think that will matter necessarily. Right protect switch. There and there. Looks good. The LED was actually working, so we don't necessarily need to worry about that. It's got to be like these other signals here for like the motor on stuff and whatnot. I guess like some just basic troubleshooting is, let me just see, that signal doesn't go, but this HD signal might be whatever this is. Let's make sure it makes its way back to here somewhere. There it is. This is the MON signal. Then ID. Looks good. LED, we already know that works. Disk inserted, we already checked that. Right protect. Looks good. BCC. Yep. And ground. All right, so everything's getting through on the connector. Now, maybe this connector was just dirty, and taking it off and putting it back on, what if that fixed it? I will just put some deoxit on there just in case. But I think what I'm going to need to do is I'm going to need to, oh yeah, by the way, look underneath here. There's our controller chip. It's actually Chinon branded. And there are two chips. This one down there, right, that one is almost certainly the motor controller IC. This is the main controller just for the, you know, entire drive itself. Luckily underneath here, other than these electrolytics, I don't see any other electrolytics except for that one. So this drive only does have 4 electrolytics on it. And I've always found these Amiga drives to be quite reliable without any issues. Does anything look out of the ordinary for these electrolytics? Nope. I don't see leakage. It all looks good. I think what I need to do next, I think I need to try to modify a PC floppy drive controller to control Amiga drives directly, so I can use IMD just to kind of get this thing running continually, or at least attempt to get it running continually. It's not exactly the right way to do it either. I'm just trying to think of the next course of action. The problem with IMD is that if it can't read the disk, it just like gives up. You saw it. It's like tries for a few seconds and then it's like done. I need something to just continually run the drive endlessly, so that way I can probe around, because maybe 12 volts isn't getting through to the speed controller. Maybe the speed controller is the problem, but we need to look at those waveforms. This is a 3-phase motor, I think it's probably safe to assume, the floppy drive motor here. So the speed controller is going to have 3-phase outputs. I don't even know what pins they would be on here. You know, maybe it's, I don't know. Anyways, we should be able to see waveforms coming out of that chip that's on the main board there. But we need to be able to run the drive continually. But what if the entire problem here is just bad connection? I mean, I don't see what looks like bad connection, but what if it's just oxidized and taking it off and on suddenly fixed it? And even if I did get an Amiga out, this might just work. That's why I'd kind of want to modify a PC floppy drive controller just so that it does work on the Amiga with IMD, or Amiga disk drives, that is, because it's much easier for me to bench test with the PC. I'm going to think about this for a second and I'll be back. All right, I'm back, and I decided to break out a grease weasel. So this is one of my spare ones, a version 4. I have another one that I keep connected to my lab PC permanently, but sort of behind it, can't easily access it. So I always get this out if I want to do some testing. So this is the Teac Drive, still in Amiga configuration mode, and I have it plugged into the grease weasel, and it's just hooked up to the straight through cable, so no twist or anything like that. And I decided the approach of using IMD to do this testing wasn't correct. And even though Grease Weasel doesn't have like a full-on track analysis tool available, like easily at least, I still found that with this Amiga drive, the Teac, if I do drive 0 GW or Grease Weasel clean command, it works. So the light is on, the drive is spinning, and the heads are currently seeking. And what's cool is if I just stop this, okay, well, if I hold the drive from spinning and I try to run this command, oh funny, I thought it was going to tell me that there was no index pulse. Well, let's try this again. I'm going to do RPM and drive 0. Let's see if this works. Okay, so that's working. There we go. So this is able to read the index pulse. If I hold the drive, it's going to say no index pulse. So there we go, no index. So that means that the index signal coming back through the cable isn't working, so it knows that it's not spinning. I guess the RPM, or sorry, the clean command doesn't even use that. What it does use is the track 0 command. So if track 0 is not being registered, that is, there's a track 0 signal on this cable, and it gives an error for that as well. Okay, so that tells us that using this -- drive 0 with this set to DS0 hooked up through the straight through cable totally works. Let's move back to the other drive now, the non-working one. and then we can start playing around with it a little bit. Now, incidentally, by the way, I did grab my LCR meter here and I tested the electrolytic caps that are on this board. All are perfect. No issues, good. Well, this was in circuit. The ESR values were all as expected. It was just all looking good. Okay, so let's pop the disk in here. It's still in the Teac drive. Same one we've been working with. Just got to hold this drive up as I do this. It's really designed to be in that chassis. There we go. Do you see that spun a little bit there? Whoa. Okay. So earlier I thought, did it actually? Yeah, okay. Now let's go back to here and do clean. Look, it's not spinning. Fatal error. Okay, that happens, by the way, because it keeps track of where the head is, and I unplug the other drive. All you have to do is a reset command, and now this will work. There it is. So it's like the motor on signal is not even getting through to it. And you see how it was kind of like turning off and on? And if we try to run the RPM command, if I can find it in my history here, where are you? Let's just type it again. So there we go. Oh, what? Okay. I tried this off camera earlier. I'm recording, yes, and it did not work. It did not work. Oh, like that. Like, what's it doing? It's like spinning when it shouldn't. So what if we try clean now? Oh, it tried to spin, but now it's not going. Is there like a bad solder joint? Is there a connection problem on here? It's like, poke at this a little bit. Okay, I'm gonna hold this board right here. That didn't help. Oh, what's happening here, everyone? Oh, did you see it was sort of spinning? Is that just by chance? I don't know. I think it was like a bad connection. I put the screw back in, by the way, so that is held down. Maybe there's just like a bad connection on the pins that go to that speed control IC. Let's keep that twisting. Look at that, I'm twisting the drive, and now it's spinning. Sort of intermittently, at least. Okay, we're getting somewhere. We're actually getting somewhere here. Let's go back to the RPM command real quick. That's not working again. Let's try if I twist. Twist and push. I put some deoxide on the connector, by the way, so it is not that. This is definitely a problem with the board. So there, that worked. Weird. Okay, well, I have some leads. All right, let's turn off the power, and I'm gonna like take this board out. We're gonna properly disconnect everything so I can properly investigate what's going on. So we do have to get all these cables off here. So I think these should just pull out. Let's lift these out. So there's that, and then we have the two head cables. These should just pop out, yeah, like that. And this one like that. And then we just have that. Let me grab some needle nose, pull that out. Yeah, these types of problems can be tricky to figure out. You know, these intermittent types of issues like this. Okay. Now we should be able to lift that board right out of here and take a closer look. So I know our issue is not anything there. This is the, I think that's track 0 sensor. This is the head itself. And then this little cable that went to there, that's for this stepper motor. So I guess this IC is for the head stepper, which is obviously working perfectly. The issue is this motor. And we just look at the traces that come from this connector that goes to that board, and everything goes to that Chinon IC. And of course, that takes the signals from the drive connector, you know, through all of this. I mean, the thing is too, is when I was pushing on the board, it seemed to kind of change it, but I don't know for sure if the problem exists on this lower board, or does the problem exist on the upper board? There's got to be a chip under here. There must be a signal that comes across this connector that's simply like motor on. Might be this. MON, motor on signal right there. So there's got to be a chip under here that's controlling that. And maybe what I can do is I just look at the output of this signal with the oscilloscope while we're trying to run the motor and see if that turns this on or not. I have to imagine that motor on just comes from this Chinon IC. Let's figure that out, actually. We can figure that out. If I just put this back here, we should be able to figure that out by just probing around on here. So it's got to be this MON signal. So it goes to there, and there, goes to there. Well, so second pin closest to the middle of the board is motor on. So it looks like this signal's pulled probably up to 5 volts through a resistor. Just switch the multimeter so we can see what this is. This resistor here, it's 10K, I think. Yeah, it's 10K. And 5 volts is right here. Yep. Okay, so that's motor on, pulled up through 10K. I wonder if there's something wrong with that resistor. It looks fine, but you know, it's possible, right? Then it goes to there. This via right here, that should be the motor on signal. I mean, I can see it right there. It goes from the motor on to that via, and yet, oh, maybe if I put the multimeter into the right mode, that's what happens when you don't look at it. Okay, so there is the via that I think it goes to. Okay, yep, we've got a good continuity there. Oh, wait a second, is there a bad trace right here? Something weird is with this trace. I'm pretty sure that's the trace. Am I recording? Yes, I am, just making sure. Goes to this pin here. Well, it's supposed to. Goes to that pin. Looks good there. And that pin, it's not loose or anything. None of these are. But yeah, there's something weird with these two traces. What are you beeping about? Oh, it's the other one that's beeping. I was like, why are you beeping? It doesn't, I don't know. The trace there just looks slightly weird. But it's the second one. Let me put a little mark on the chip where the actual motor on signal goes to. So motor on is that right there. I just put the gold mark. Makes its way to the Chinon chip. Well, it's a huge mark. Basically, right about there. Okay, so what we need to do is put this back together. I need to look at the motor on signal on the bottom of the drive that's going into this little resistor here. We need to make sure that that actually is looking good, and then poke around and get the drive to kind of spin and not. Obviously, there's a motor on signal that comes from the connector that goes to this as well, so that needs to be correct. Don't see any issues. Yes, I don't know which pin off the top of my head is motor on, but it's going to be one of these. What we need to do is get this back together and take a look with the oscilloscope at the motor on signal there. You know, it'd be funny if it just works now. Like after I poked around at it, that would just be my luck. But let's give this a try. All right, I do need to put a disc in for the motor on stuff to work correctly. And yes, I don't have anything hooked up. None of the other signal wires are plugged into this right now. I just leave this stuff off right now, like the heads and whatever. Doesn't matter that that's not plugged in. Same with that. Because we just need to see if the RPM stuff works. Because I could just keep running that command over and over again to get this to kind of spin, or try to spin. Right, let's get the oscilloscope ready to go. I'll use this one. All right, so let's set this thing up. We're going to do trigger mode as auto, so it's just continually running. Trigger source is 0, or track 1. Channel 1. Channel 1's on. DC coupling, that is fine. 10x probe, that is how we have this configured. 10x. Oh, I'm almost out of battery power. Let's change this to 1 volt per division. I'm assuming motor on is just going to be, that is going to be just a 5 volt signal. I do have this clipped onto ground on one of the capacitors that's coming in off the power here. I can't really see this at this angle. I think you can, but I can't. Let's just move this a little bit better here. Whoop, this is all sort of falling apart, everyone. Okay, I think we're ready to go. Let's power on the power supply. Didn't do anything at all. Let's see what we see here. Okay, my assumption is this is an active low signal, so that the Chinon chip there pulls this down to ground, and that's what turns on this motor. I'm on this resistor, which happens to come from the MON signal right here, motor on. I think I can just pull this down. Oh, I wasn't looking. I saw it spin there. But what I need to do is just pull this down to ground because it's pulled up right now through this 10K resistor. So we can just pull this down to ground and see if this spins. That'll help us identify like where the problem lies. But we're just going to stick on there. We'll just watch that line. And I'm going to run on the computer the RPM command, which should make it spin. And it is still up at 5 volts. So that means, of course, the drive is not going to spin because it won't be instructed to. So why don't we use a clip lead, and we are going to force this to ground and just see what happens. My assumption, hopefully, it's an open collector output on that Chinon IC, which means me pulling this up rudely. You know what? I'm just going to do it through a resistor. No, you know what? Screw it. I don't care anymore at this point. I am just going to do this. So we're just going to clip on this clip lead to here to ground, to the drive's ground. And this is ground now. And theoretically, I can measure this output of this resistor here. So there's our 5 volts. And watch. There it is. So it turns on perfectly. So there is no problem with the motor controller that's on this drive at all. See? The issue exists from either the Chinon IC or the connection from it, or maybe from the cable to the Chinon IC. Let's go back to monitoring that signal. I mean, we can monitor it anywhere. We can pick it up. Well, we'll just pick it up right here again. So there, it's up at 5 volts. And if I turn on, I'm trying to get it to read the RPM. Nothing. Okay, everyone. Let's think about this for a sec. I think I don't even need the motor necessarily. Let's turn the power off for a sec. I don't see why I can't just run this drive board like this out of the drive. Nothing was plugged into it anyways. So that way we can probe around directly on here and check the motor output signal on the Chinon chip, right? We could see the output to kind of see what's going on here. Right, and maybe I can find a datasheet for this. I didn't even think to look for that. All right, let's turn this on. So we're going to go to the motor on signal. That's right here. I know it's this via. So when I hit the power, that should go up to 5 volts. I'm going to try to read the drive right now. It's not doing anything. Oops, that was my fault there. What I can do is I can poke around. Oh, you know what I need to do is I need to write a batch script that just runs the speed command over and over again. So that just keeps trying to run the motor. It's currently just running repeatedly. So it just runs, calls itself, runs, calls itself. So right now this thing should be trying to spin the motor indefinitely. So the problem is not an issue from the chip to the via to this, to the motor speed chip, whatever that's on the other board. Because this is, I'm on the chip itself, definitely on the right trace that goes to that via and goes to there. So yeah, there's nothing. But while I'm just going to go on the via itself and I'm going to push on the board. Just see if this, like, bend it, anything. I'll try to do this in view of the camera. So on the right via. Wait, am I just not on the via? Yeah, I think I was not on it. So I'm bending this board, and that does not seem to do anything. And believe me, on the screen I can see it saying, like, you know, no flux, no index, no index. So it's trying to read this. All right, let's go back a step, and let's find the motor on signal that's coming from the grease weasel. So there are the drive select signals, but pin 16, motor on. Now with the PC stuff, motor A, motor B, that's the whole flip thing, but generally just pin 16 is motor on, and it goes to all the disk drives. So drives in the old days would all spin, and then later it would be only spinning if they were also selected. There's like some logic on the main board. So pin 16 is what we want. Let's double check that we are actually getting that signal. All right, so I'm on the motor on signal. I can test this by just stopping the batch file. Terminate batch file. Yes. Okay, so now it's high, and as soon as I run the batch file, it goes low. Right. So that's the grease weasel trying to turn on the drive motor. So let me find the trace from here going into the Chinon chip. So it looks like it goes to this resistor, which is not installed, across it to this via right here. You will see it go up and down, and that's just because, like that, that's because the timeout is happening on the grease weasel, and the batch file just runs it again. In fact, let's change this to roll mode, and then that will be a little more obvious. That's the normal motor on pulsing that's happening. Cool. That's good. That will help us identify like where it is on the Chinon chip. I'm thinking the Chinon chip is bad, unfortunately. I mean, if we see this signal going into it, and we don't get that motor on signal coming out, then I mean, what else is there? I suppose I could just wire the motor on signal directly from the cable right to the motor on. I might just do that. That just might fix it. I'm just going to bypass that Chinon chip altogether, if we don't find another problem. All right, so let me try to get situated. There's the circle. It's the third via away from the circle. Okay, let's here we go. Oops, the ground lead fell off. That will not help us whatsoever. Third via away. There it is. There's our signal. It very clearly goes right here, I think, to the Chinon chip. So yeah, third via right here, and yeah, it goes right here, and that's a nice solid connection. And then the output is there, or rather here, and it's never doing anything. Screw this chip, this Chinon chip. I'm just gonna I'm gonna jump over it. It's junk. Yeah, I mean, what's the problem with me just the signaling's the same. It's active low, which is exactly what this is. So I'm just gonna cut the trace coming out of this, and I'm just gonna jump directly from that third via right over to that via. I think that should fix it, because I think this chip is just bad. Cool, let's do that. So I'm gonna grab my little engraving tool, which is somewhere. Here it is. We're gonna turn off the power, and I'm gonna stop the grease weasel application so it's not gonna run as well. Terminate batch file, yes, okay. So here we go. I'm gonna do it. Can you believe it, everyone? But yep, this is what's gonna happen. So we're just gonna cut through this trace right here. And we'll just make sure that there is no more connection. I mean, it probably would have been okay, but just to be sure, I wanna make double, triple sure. Okay, so we're in continuity mode. Yeah, and it's not connected there anymore. So it's broken. Okay, cool. All right, let's bodge right over that. Now, I think what this means is that whenever the motor on signal comes on for any disk drive, the motor will spin. But I don't care. It means the drive will work versus not working. And that, to me, is more important than the motor not turning on all the time when it shouldn't, because that's exactly what will happen now. And obviously that Chinon IC has some logic inside where it looks at the other signals, like the select signal, and then it only turns on the motor when it should be, but we know select signal was working because the heads were moving around and the light was turning on. None of that would work if it weren't for the fact that the select signal was getting to that chip and the internal logic was working. So it feels like it's the output driver that's on this, that's the problem. So we are just gonna, let me just melt these, the solder on these vias here. It was right there, and it was right here. All right, so there's the bodge. Motor on is now just bypassing this chip, just goes straight to the motor on signal. And well, the input still goes into here, so it can use it for whatever logic and stuff. And let's see what happens. And I cut that trace, so therefore the spurious signals that come out of there will never really cause any issues. And the only issue really is that generally these chips, when you put a disk in there, it senses it and it will spin this just to kind of get the disk locked into place. That's not going to work, not until the drive is accessed for the first time. So this is not ideal, but if this makes this drive kind of run again, I'm still going to consider it a win. Sorry about that. You were hearing a whole bunch of backup audio. My microphone died. Anyways, it goes without saying that the right way to do this would be replace that chip or replace this board. So I suppose if anyone has one of these boards, just this one with the Chinon chip on it, that's compatible with the rest of this mechanism, let me know, because that could just, make this work perfectly again. So my assumption, like I said, is that chip is the problem. All right, if I power this on now, this should not spin. Disk is still in there. Hopefully nothing bad happens, but here we go. 3, 2, 1. It didn't do anything. I'm going to run the batch file. There it goes. Ah. Okay, so this is interesting, everyone. Why is this happening? So it's obviously spinning, and we can see it kind of stop and start normally, but I am not getting any index stuff. Oh, is that because I have all those other wires disconnected? Let's get those connected, actually. So let me stop the batch file. I wonder if those other cables that I unplugged have something to do with the index sensor stuff, all this stuff. So let's get this back in, and then we will test again. But the fact is, it's spinning, so that's something, right? All right, so all the cables are reconnected. So let's give this another try. Keep your fingers crossed, everyone. Keep your fingers crossed. So we'll get that in. Good, there we go. And here we are. So this is the little batch file thing that I was running. Let's power on the drive, and let's run this again. Okay, yes. Oh no. Right. That's odd. Okay. So that kind of tells us something. That tells me that the Chinon chip, the problem with the Chinon chip, it's the input, not the output. And I bet you, so right now, even though the drive is spinning, you can't really see it very well, but the LED does come on while it's spinning, so that's working. Look at that weird spurious reading. And now it's just sort of sitting here doing nothing. Weird. Grease Weasel crashed. Grease Weasel doesn't like whatever was going on there. So my assumption is that the motor on signal that goes into the Chinon chip along with the drive select signal, there must be a problem around that specifically. And maybe it's the internal logic inside the chip that's bad. It's not the output driver that drives the motor on signal that I cut that trace on. It's the input logic. So if it's not getting a motor on signal, but say it's getting drive select, it turns on the light, but it's not turning on the motor through the output. And because the logic is broken inside of the chip, now the motor is turning on because I'm just forcing it on. And yet, because the chip is so like broken on the inside, I can't even control C out of this. What if I unplug the Grease Weasel? There we go. Device disconnected. Yeah, the Grease Weasel was not happy about what just happened there. But let's try it again. Yeah, so it is, like I said, it's my assumption that we know the motor on signal is getting to that chip. We know the drive select signal is getting to that chip because the light turns on, and the light is generated by that chip as well. We know that the heads were moving, and again, that is because the drive select is selected. If you don't have the drive select on, motor might spin, but without the drive select, with the motor spinning, that still doesn't mean the drive is going to work. And we can see that there, like, worked one time there. And we know the motor on signal itself is getting to that chip. I mean, we know there's not a wiring problem because I jumped right on the via that goes into that Chinon chip, and that's now what's turning on the motor, and it's turning it on perfectly. We're getting a pulsing thing that's happening. That pulse wouldn't happen normally, by the way, because there's some hysteresis, I don't know if that's the right word exactly, in the Chinon chip, where when the motor drive enable signal goes away, it keeps the motor spinning for a little while. But yeah, that something's wrong on the input side. And we can see on the scope, there's nothing wrong with that signal. It's going 5 volts, pulled up to 5 volts. If it was like, at 2 volts or something, that could be an issue. Pulled up to 5 volts perfectly. There's a pull-up resistor on the right here that I actually came off of. It's this pin on the pull-up resistor. Well, you can't see it. There, that pin. And yeah, let's just touch this a little bit. See if that does anything, like the capacitance from my finger somehow. No. No, that chip is just bad. Bad, bad, bad. And the rest of the chip works. So the chip is getting power. It's able to move the heads around perfectly. It's turning on the LED. It's like doing all the other things it's supposed to do. It's talking back to the drive controller, like sending the index pulses sometimes. But it's sending the track 0 sensor signal. All that's working. But yet, it is not sending the index signal. And without the index signal, the Amiga is not going to work with this drive. Nothing will work with this drive. So that is a problem. So we can do the RPM command, or the clean command. So grease weasel clean drive 0. The motor's going to spin. The light's on. The heads are moving. That is all working as it should. And unfortunately, everyone, I have some parts drives, but the parts drive I have for the Amiga do not have that Chinon chip on it. It's their Neutronics drives. So I can't steal that chip off something else. It would have to come off another one of these drives. And it's quite possible that like an Amiga 2000 drive that's damaged, you know, has mechanical issues, that chip might be the same and might work. So I'm kind of stuck again with no disk drive for the Amiga 3000. How annoying. So I guess for now, what I'm going to do is probably put the machine back together. Obviously, I have to work on it again because I have to fix the flicker fixer, or try to fix the flicker fixer at least. And I guess I will have to try to source one of these drives or a parts drive. And I guess I'll put the part number for the Chinon chip on screen here, having reviewed the footage during editing. So if you have one of those chips or one of those boards or a parts drive that's all damaged, but the chip's good, or if you don't know the chip is good or not, I can take the chip off of another drive and stick it on this one, which obviously mechanically seems perfectly fine. Then I can hopefully get this machine or this drive working and put it back in the machine and then have a working machine. So I was just upstairs editing the footage that I just recorded for, you know, trying to repair this disk drive. I even put a label on here where I actually wrote what the problem was: bad Chinon IC. I was pretty much sure of that based on all the evidence I just saw. But I just had a realization while I was sitting there editing, and some of you watching may have already realized this. I'm used to working on floppy drives like this, 5¼ inch drives. This is typically what I'm working on repairing. I think I can only count on one hand how many times I've had to repair a 3½ inch drive that didn't have a mechanical fault, like it was gummed up or, you know, whatever, like the Macintosh drives, the gear was bad, stuff like that. What's a big difference between these two drives? Well, obviously, ignoring the format difference, one big difference is the motor that spins. And if we look at the bottom of this 5¼ inch drive, this motor will just spin anytime the motor on signal comes through and it's satisfied. You know, there's a similar controller chip on here to the Chinon. So with the drive select, the motor on, all that stuff, you know, it'll spin this drive. Well, that's actually not the same as what happens on 3½ inch disk drives. These have a sensor, and I talked about it earlier in this video, that detects if the drive or the disk is inserted. So when you put the disk in, it goes down, it touches one of these sensors, and the other one is for write protect. Well, I'm pretty sure that while the disk is not in the drive, unlike these types of drives, the controller will not even issue the motor on signal at all unless the drive is, or the disk is in the drive. Meanwhile, 5¼ inch drives, and this is not a Chinon, this is a Fujitsu drive, it'll just turn on the motor all the time. So when your PC first turns on, it goes, you know, does the head seek. Well, the light comes on, the heads move, and the motor comes on. But with these 3½ inch drives, that does not happen. The light comes on, the heads move, but the motor doesn't. So in all of that troubleshooting I was doing, the one thing I didn't test is the actual drive insertion switch. Is that actually making good contact? Because if it's not, and the Fujitsu chip doesn't think there's a disk in there, well, it's not going to spin this. And remember how it was sitting there on the bench, and then suddenly, whoosh, you know, the motor spun for a second, which is normally what happens when you insert a 3½ inch disk in the drive. It needs to spin the motor for a split second just to kind of get the cam or whatever it is, like locked into the bottom of the disk here. Well, that's not happening. That just happened randomly when the disk was in there. And I never saw the motor try to spin when there was no disk in there. So I have a feeling if I take this drive apart again and we test that switch for the insertion, that it's going to be bad. And for all I know, the write protect switch is bad too, but we never really got to that point for testing. So yeah, and then I will just need to undo that bodge and repair that little tiny break I made in the trace, if that's the case. So this drive can be, you know, put back into service if I can get that little micro switch working. And they look custom. It's not like a off-the-shelf part. It's a special part that has two little posts sticking through. And anyways, let me get this drive apart and let's test this. Because I'm pretty sure now, in watching that footage, that is the only problem with this drive. That is it. Bad switch. And actually, just for some instant gratification, if I just take this bottom cover off here, I just set it back together so I wouldn't lose the various pieces. If I take this bottom cover off, I bet you we can very quickly rule out or ascertain if that is the problem. Now, it's really funny because I haven't done a lot of repairs on 3.5-inch disk drives, but I've worked on a bunch of them, you know, cleaned the dirt out of them and lubricated them, this, that, and the other thing. I've never run into one with a bad switch before. And I have several of these Chinon drives that I have in Amigas and stuff, 500s and 2000s, and they all are fine. I've never had issues with the switches being bad, but that's just most likely what's going on with this thing. It's just gotta be. Let's first start with the write protect switch. So this is write protected. I'm assuming, how's this gonna work? So let's go to the WP pin and ground. Okay, no continuity, and VCC, no continuity. So I'm gonna put that disk in. Oh, actually, let's flip the write protect switch. So it will push on the switch. Now let's check between the WP pin and ground. Okay, we're getting it. 13 ohms, 12, that's actually not great. Should be like, you know, over, you know, just a bit over 0. Right, now I'm pretty sure it's this DI pin is the other disk insertion. Let's check to ground. Nothing. Okay, well, let's see. DI goes to where? Right here. Okay, so that is the actual physical pin. And I'm pretty sure, let's see, write protect. That goes to here and is correct. And then ground should be the pin in the middle. There's an LED in the way. But yep, okay, ground is in the middle. All right, well, I mean, that's our issue right there. So disk insertion is right there. So I'm going to poke at the switch a little bit. I mean, yeah, there's nothing on there at all, 0. In fact, we can switch this out of continuity mode. And that way we can see if it's like something really high resistance. Huh. Yeah. I'm sure if I take the disk out, it's going to be open. So it's just going to say OL. How about now? Yeah, OL. Oh, wait. Wait, what? Okay, what about the write protect switch? Okay, so this is the general state of it not being connected. And if I put the disk in, this is write protect. Oh, that looks bad too. All right. Well, so both of them are bad. Ah, you know what? Look at this. See how they're kind of shiny? Poke at it with the thing here. Is that like some kind of contact cleaner? Did someone try to clean this or do so? Oh, ah, moves around as well. Interesting. I did not do this. This was not me. So someone else has done something here. I'm going to spray contact cleaner in here, and we're going to see if that makes a difference. Okay, sprayed a little bit of this QD electric cleaner in there. It's safe for plastics. Let's see if that made any difference. All right, first off, let's see what this looks like now. I don't have a disk in there. So similar, whatever mega ohm. That actually could be on the sensor side, like on the chip side. So let's pop this disk in here. All right, put the disk in. So let's see what happened. Did this just magically fix it? Sure did. That is disk insertion. And then write protect. 1 ohm, even better. So it's still not perfect. So I probably just need to spray a little bit more contact cleaner in there, manipulate it. Oh, look at that. I moved the disk around. That was the problem the whole time. Now, I was gonna say something I can see in the comments now. Hey, dummy, you should have known that. That's common with these Chinon drives. Why didn't you know that already? I didn't know it. And I wanted to show you that in repair, you just run into all sorts of problems. And while people may be like, I was already super familiar with that problem and you should have known it too, that's just not how it works. Besides my own Amiga when I was in college, I probably only worked on like 5 or 6 of them since. And not all of them have these drives. Some of them have the Neutronics drives, like my Amiga 1000. And most of them, well, all of the ones with the Chinon drives, I have never had one that had this particular problem. And I have stacks of 3.5-inch floppy drives from all sorts of brands, like the Teacs and whatnot. And I've never had an issue where the drive wasn't working because the switch was bad. So while this problem, I'm sure, exists, it's just not that common. Now, it could be that with this generation of Chinon drive from 1990, maybe they had a bad batch. Maybe on Amiga 3000s is like totally common problem. But I certainly didn't come across that in my searches, because I did do research ahead of time, which is how I found out that you need to use this particular Chinon drive in the 3000 because it's the only one that actually fits in there. So yeah, I just kind of wanted to show you. I mean, not that we've seen this drive work yet, but I'm sure this is the problem. I'll just undo the bodge wire I put in here, and we'll get this drive working again. And like with all my videos, I really like to just show that when you're doing repair work, you just never know what you're going to run into, and you can get caught up on issues. And you know, I've repaired so many 5.25-inch drives, and they don't use a disk insertion sensor. So it's just not something my mind was even really thinking about. And I think that's what kind of caught me out. Oh, I can never remember how to get this thing apart. There we go, like that. So let's just get this drive apart so I can undo my little bodge that I did. It just takes a second now that I've done this already. Let's get this connector out. This is the one that's a little bit hard. And I also want to show in this video, you know, the problems you can run into all are varied. But the other thing about this drive is it did not have bad caps. That was not the issue. The issue was definitely that bad switch. Okay, let me get this off of here, and then we will have a drive that I can test in a second. Once the soldering iron warms up, we'll have a drive I can test and make sure that this actually works. All right, there we go. I just used a little piece of the bodge wire. I cut it and I connected it to the trace that goes into the chip. So no one will ever see that. It's on the inside of the drive. All right, everything is reconnected. Why don't we just get this hooked up to the grease weasel so we can do our testing again. There's our little switch guys right there. Yeah, there's a bunch of like kind of oily goop around them. It's really hard to see on the camera, but something was on there. Was it like WD-40 maybe? Let me get some, I don't know, I have a Q-tip or something. I could try to clean them. That does not look like what deoxit looks like. Interesting, very interesting. So this might have been an attempt or a previous fix that someone tried to do, and they should have just used some of this contact cleaner here. Just a tiny bit is all you really need on there, just enough to kind of get it in there. And then I'll just use this cotton bud, push them down a whole bunch. And that QD stuff is pretty good. Like it kind of gets rid of any oil, whatever film that's on there. And while it doesn't really coat stuff, if it's all corroded and oxidized, which, you know, I don't know, maybe that's what's going on in here, then maybe I should, yeah, I'll put a little deoxit into these if it's working right now. Let's first test that. All right, we'll know very quickly if this is working, so I'll just run this. Oh, maybe if the power supply were turned on, it would work better. Let's try that one more time. Oh yeah, the disc is spinning. I can tell. Wow, okay. I guess that was our issue the whole freaking time. So lesson learned, always check the micro switches on 3.5-inch drives if you're having problems just like this. You know, the symptoms were there that I should have been able to realize that just by looking at the LED being on, head moving, but yet disc not spinning. That's the key factor. No disc spin, it's got to be the disc insertion sensor or switch that's causing the problem. Now I could just run my little speed utility here, which will just continually test. There it is. So if we take the disc out, let me demonstrate this by flipping this over carefully. Okay. Oh, it's interesting. Okay, so it's having that same pulsing thing. But when we pop the disc out, how do I do this? I have to hold on to the black plastic part. So there it is. There's the spindle no longer spinning. But as soon as I put this in, it starts spinning again. So it's that darn tootin' switch. So, see? And yeah, even without the disc in there, you know, it's not spinning, but the LED, which is very hard to see, just see it kind of goes off and on. So same exact behavior we had before. I guess I should spend a moment to clean the heads while we're here. All right, so it's cleaning, it's spinning. That's the Hall effect sensor that's picking that up. There's no index hole on a 3.5-inch disc, obviously. And we can run the clean thing. I should clean the jack screw because that looks gross. It's kind of junk is coming off there. It's not terrible, to be honest, though. And you know, it's obviously still slippery. Okay, so I'm just going to use a little bit of this white lithium grease just on the screw there. Just a little bit on there. It kind of moves itself around. You know, when it goes through its normal head operations, that will spread the grease. So I'll just run the clean command now since it's still sitting there. Okay, I got to reset the thing because I moved the heads. It did not like that. So now I do clean again. You know, maybe I put too much on. Look how it immediately got dirty. You see that? Like the white grease is now kind of crusty looking. That's funny. I am going to try to get that glob off of there though, because it kind of bugs me. There we go. I'm happy with that. All right, so heads should be clean because I used this cleaning floppy. Excellent. I think all that's really left to do is I'm going to drop a little bit of deoxit, just the D5, which is the pink stuff, which is what I have in this little squeezy bottle here. People ask me how I get this. I just take the spray can, just spray it in there. And Jerry Ellsworth told me the special trick you need to do so when after you do that, if you don't leave the cap off for like a few days so all the propellant can evaporate, when you try to squeeze a little bit of this out of the squeezy bottle, it'll just like gush a whole bunch out of there. That's because there's still propellant inside the liquid. If you just leave the cap off for a while, and deoxit itself is not a volatile compound, so it won't like evaporate on its own. Once it sits for a few days, it won't have the propellant anymore, and then you can very carefully meter out just tiny bits of it out of these squeezy bottles. Thank you, Jerry, for that little tip if you are watching. So what I'm going to do is just very carefully just drop a tiny bit into the switches. There we go. That's all. Just enough that it's coated inside. Oh, look at that. When I push it, makes the disk drive spin. Well, there's a good test as well. If you're not sure if this is a problem, just push on the disk insertion switch. So really, I feel that like the QD electric cleaner like cleaned up the contacts, and then the deoxit just sort of keeps them from getting reoxidized and failing in the future. But it looks like it's the innermost one that makes the spindle spin. And then check between ground and the switches. So this is right protect, 0.5 ohms. That looks fantastic. That's right protect. And the other side, disk insertion, 0.6. That's perfect. This drive is working. Drive's back together. I can peel this sticker off. So here's my new sticker. I'm going to put it right over where it said dead. Amiga 3000, dirty disk insertion right protect switch, fixed 8th of June, 2026. And really the final validation step, which I haven't done yet, we know the RPM is working, the heads are moving. I really need to just make sure I can read a floppy disk in here. So in goes the 720K disk. I will just right protect it. First we'll turn on the power. Okay, it spun. I heard it like whoosh, lock in the disk. Good. I never remember the exact syntax for reading. So Grease Weasel, read, format. This is IBM 720. That is the type of disk. And then we output to a file. I'm just going to put it to here, test.image, I guess. That should be enough. Oh, yeah, that's normal. That's because I unplugged the drive and powered it off, so it lost track of where the head is. So you just do a reset first, and then run the read command again. There it goes. This is a perfect way to test this drive. Grease Weasel is a great tool. It really is an absolute wonderful project. And what would make it the ultimate, in my opinion, is just that user interface to allow you to very easily control it for diagnostic purposes. Obviously, reading a disk like we're doing here is excellent because it is error checking. So if there are problems with this disk, it will tell us. But you know, you got to use a good disk when you're doing this process. But this is validating that this drive is working well. But as I was mentioning earlier, if we just manually control the signals, or basically have an output display of all the signals, there is a way to like manually read each signal. But if we can see write protect status, we could see the index sensor, we could turn motor on and off, we could turn the density select on and off, you know, configure it for Amiga drives, PC drives, any type of floppy drive, and then have it be able to turn on the motor, just keep it on, and then have it continue to be able to read tracks over and over and over again, the same exact track. And if it's using like an IBM PC format, then, you know, tell us that it's reading correctly over and over and over again, or, you know, any errors that are happening, plus that track offset stuff, and allow us to move the head around manually while it's reading. Like all that stuff that IMD could do would make it amazing. It just finished the read. This disk drive is working flawlessly. That is so exciting to me. That means that I can take some time to put the Amiga back together, and now I have a fully working disk drive. And it was just the switches. It was just these little switches the whole time. Okay, so there you go. Chinon FB-354. If you have one of these and it's doing this, check the switches. Use contact cleaner. Hopefully that will get you up and operational again. And this video is just another example of what the reality of doing computer repairs is like. You go off on tangents, you end up with a conclusion. You're like, I am sure this is the conclusion. I mean, I probably would have taken that chip off and switched it with another drive. If I had another drive handy, I would have been swapping chips. I am glad that I just took a moment to kind of step away and process what I had seen. Of course, editing a video helped me do that. But that sort of processing time where I was like, oh, wait a second. I came to that realization when I was sitting up there and I was like, I got to come down. I got to try this out, because that's probably the problem. And yeah, it was. Anyhow, there you go. I hope you enjoyed this repair. If you did, thumbs up. If you didn't, you know exactly what to do. Sorry about the bad audio in the middle of the video. It sounds terrible. I hate using the backup audio, but I'm glad I have it, because it would have been a huge section there with no sound. And I probably would just abandon this entire video, because I wouldn't have wanted to voice over that whole section. But if you like this video, thumbs up. If you didn't know what to do. Huge thanks to my supporters. Names are going on the side of the screen. You can become a supporter too if you want. There's links down in the description below. Comments, thoughts, all those things. And I think that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.